Now let's say we have a function that has two vertical asymptotes. The first thing that you need to do is factor the function. Since we only have x minus 2 in the numerator, we're going to keep it that way. And x squared minus 2x minus 3 can be factored as x plus 1 and x minus 3. Just as a reminder, the x-intercepts will come from the numerator, and from the denominator, you will have the vertical asymptotes. So let's find the vertical asymptotes first. We're going to use x plus 1 equals 0. So the first vertical asymptote is at minus 1, and the next one will be at 3. X equals 3. So your vertical asymptotes are minus 1 and 3. And you can also figure that the domain will be from minus infinity to minus 1, from minus 1 to 3, and from 3 to positive infinity. Now that you have the vertical asymptotes, let's sketch those values on our plane. That is minus 1 over here. And the other one will be at 3 over here. Remember, those are not actually part of the graph. They are just there to allow you to sketch the actual graph. The horizontal asymptote, just keep in mind that you need to use the leading terms. So this is a degree 1 versus a degree 2. So the obvious winner is the denominator. Whenever the denominator is the obvious winner, you're going to have your horizontal at y equals 0. So let me use another color. Let's have that horizontal asymptote at 0. And now it will be time to find the x and the y intercept. The x and y intercepts, just remember the answer to the question, how much is y when x is 0, and how much is x when y is 0. If you plug this x of 0, you're going to end up with 0 minus 2 divided by 0 squared minus 2 times 0 minus 3. So that's going to be minus 2 over minus 3. You get 2/3. So 0, 2/3. Let's try to have 1/3. 2/3 would be about here. Now the x-intercept pretty much comes from the numerator. So you could say that 0 is equal to x minus 2 divided by x plus 1 times x minus 3. And as you can tell, when we multiply everything by x plus 1 and x minus 3, you're going to be left with 0 is equal to x minus 2 and x being equal to 2. So basically just solve for the x in the numerator. So you get 2, 0. That's 2 points in between the vertical asymptotes. Now, let's find at least 1 point outside the boundaries of the asymptotes. So perhaps we could use f of, since we have a minus 2 here, another option would be minus 3. And on this side, we could use 4, we could use 5. So let's try with f of minus 2. And we're going to end up substituting that on the original function, but the factor version works better. So minus 2 plus 1 times minus 2 and minus 3. So that's minus 4 divided by, we're going to end up having minus 1 and minus 5 if I'm not mistaken. So this is gonna be minus 4 divided by 5. So we have to locate a coordinate that is minus 2 comma minus 4 divided by 5. So minus 2 minus 4 divided by 5. So minus 5 over 5. Minus 5 over 5 would be minus 1. So it'll be around there, very close to the minus 1. If you want to move on to a value that's further away from the vertical asymptote, you could. I'm going to stick to one coordinate at the moment, and then we're going to try to figure out the behavior. So let's try to use a 4. 4 minus 2 divided by 4 plus 1 times 4 minus 3. And that will get you 2 divided by 5 times 1. So that is 2/5. So that's going to be very close to the horizontal asymptote. So I'm going to do my best to use that point. Now, those points might not be enough to sketch the graph. So one option is to find the behavior near the asymptotes or use points that are very near the asymptotes. The asymptotes, the vertical at least, are at -1 and at 3. So what would be a very near value to -1? So you could say that you have -1.1 and you could use -0.9. Those are very, very close to the -1. Same for the 3, you could use 3.1 and you could use 2.9. Those two are very near the 3. So what would happen if I evaluate the function with -1.1, with 0.9, with, let's say, 2.9, and with 3.1? Since I'm very close to the asymptotes, I'm trying to figure out the sign more than the actual value. So let's say I will be evaluating all of those values, and let's see where we get to. So if I substitute -1.1 and then -2, and down here -1.1 plus 1 times -1.1 minus 3. The thing here is that we're going to try to stick to the signs. So this number will be negative. This number, since -1.1 plus 1, you have the negative being the winner of this operation. You're going to have a negative sign, and this one will be negative as well. So you're pretty much working with a negative being divided by the multiplication of two negative values. So negative divided by this multiplication will end up as positive. And if you divide a negative number by a positive number, the answer will be negative. So that means that from this last known coordinate, the graph will go into the negative direction, since -1.1 is very near or very close to -1, but -1.1 is on this side. So that means that as we get closer to -1.1, the direction will be negative. And from this point, we're going to try to approach the horizontal asymptote like this. Then if you use 0.9, now you're trying to see whether the graph will go in the positive direction or in the negative direction on this side of the asymptote. On the other side, it was either going up or down once you approach the asymptote. So if you, this is supposed to be negative. So if you use minus 0.9 minus 2, let me make a bit of room here. And let's try to use a different color. So that would be minus 0.9 minus 2 divided by minus 0.9 plus 1 and minus 0.9 minus 3. So this will end up as negative divided by this operation will be a positive number and this operation will be a negative number. So you are going to end up with negative divided by negative. And that will lead to a positive number. So the meaning of that is that from this last known point, we're going to move in the positive direction. We're going to move in this direction. Then, if you evaluate with 2.9, you're going to try to figure out whether you're going to get a positive or a negative number. So you're going to go for 2.9 minus 2 divided by 2.9 plus 1 and 2.9 minus 3. So that's going to be the 2.9 exceeds the minus 2. So this is going to be positive. Then 2.9 plus 1, also positive, and 2.9 minus 3, that's negative. So you end up with positive number divided by negative number that is negative. So that means that on this side of the vertical asymptote, you're going to have a negative direction. So from the last known coordinate, we're going to be approaching negative infinity, and then we connect those two dots. And finally, we're going to be evaluating with 3.1, and I can already see that this point is over the asymptote. It would be very weird that this goes in the negative direction. So if we perform the evaluation, I would be expecting to get a positive number. And since this point was under the asymptote, I was expecting a negative direction. I will be expecting a positive direction over here. So let's just use 3.1, and that's going to be 3.1 minus 2 divided by 3.1 plus 1 times 3.1 minus 3. So that is a positive number, and another positive number. If everything is positive, you end up moving in the positive direction and approaching the horizontal asymptote. So let's just highlight our final graph. The final graph is going through that point and then approaching the other asymptote. From this coordinate, we're moving in the positive direction, so moving up like this, and then we're going to be approaching the horizontal asymptote. From this coordinate, we're going to be approaching plus infinity. From this point, we're going to be approaching the asymptote going in the negative direction, and then the connection between those 2 points. So the coordinates that we were using are highlighted here.